Thank you all for joining our session here this afternoon. It's a pleasure to have you. My name is Stefan Guselnik. I'm a senior partner with BCGX. Within BCGX, I'm responsible for the topic of climate tech. And I'm very excited to welcome you here and host this afternoon's colleagues. At BCGX, we are very focused on going after growth opportunity, which we see in climate tech. We work primarily with large corporations to help them make progress on their transformation journey. Anything from understanding the starting point in their footprint to rethinking, re-engineering their core operations to driving growth in the green and climate tech space. And I think we have an exciting panel here today to share some insights and learnings from different perspectives on the opportunity which we see in green technology. I'll have my colleagues introduce themselves. Anika, please.
Yes. Oh, you can hear me very well. You must the slides. But everybody for joining. I'm Kanika. I'm a venture architect at BCGX, which Stefan just explained. I've been building ventures across a variety of industries, taking them from 0 to 1 for the past 7 years. In the past 3 years, have got really, in the green tech space, where a lot of our focus has actually been working with scale-ups, startups, and investors that are trying to make it. To you, introduce yourself. Oh, sorry, Vuk, to introduce yourself.
Indeed. Nice to be here. My name is Vuk Trifkovic. I'm also managing director and partner at BCGX. And my focus is really on making sure that we build the next generation of corporate and startup innovation in green tech space. My background is in product management, and I'm helping those companies scale up on their journey faster. Thank you.
Hello. Okay. Sorry for the technical challenges here. So I actually wanted to start out with a bit of an icebreaker. So to get to net zero by 2050, we're obviously going to need a lot of new technology. So based on recent estimates, what's the technology gap to be able to get us to net zero by 2050? So show of hands. Option 1, about 0 to 10% of the tech is not yet available for scale today. Okay. How about 2, 10 to 20%? All right, a bit more. How about 3, 20 to 30%? And how about 4? Okay, so we've got quite a wide range of answers. But the short answer is actually 4. So to get to net zero by 2050, based on recent estimates, and there are quite a lot out there actually, we actually are missing about 50% of the technology that we need to be able to achieve net zero by 2050. So what that means, right, is invention is really going to be key. With less than 30 years to actually get to net zero, we can't rely on incremental innovations. We're going to really need to move fast to actually invent and deploy those breakthrough technologies that are really going to move the needle. And for those technologies that do exist today, as well as the ones that we're going to invent, we've got to actually deploy them a lot faster, right? So that's going to take innovation in the broadest sense. So it's really cool that we're in this Congress, together with a really wide variety of ecosystem players, right, all the way from policy to investors, and thinking through, right, how we can actually innovate from a business model perspective, because that's what it's going to take to get us to net zero. So quickly, in terms of how we're going to run the session today, I'm going to take you to a brief introduction of the topic about fast-tracking green tech deployment. We're going to introduce our amazing panelists that have decided to join us today. And then we're going to engage in a bit of a roundtable, candid conversation around their experience actually in scaling up the green technology that they're, building. So during that time, we also hope to engage, right, the audience in being able to ask questions. So if you're in this room today, I'm sure everybody's well aware, right, of the fact that we're not on track to achieve that 1.5 degree pathway that's been set out by the Paris Agreement. So we've essentially got to half our emissions by 23, half them. And we're actually set to rise in emissions by 11% by the end of this decade. So not on a great trajectory, but that's why, again, it's great that we're brought together today to talk about exactly innovation. And based on the icebreaker, but I explained that the technology gap is actually massive. So with the technologies that exist today, they're actually able to address about half of those 51 gigatons of carbon equivalent emissions that we emit annually, right? So that's things like solar, like wind, operational optimization, natural carbon sequestration, things that are already working well today, but just need to be scaled up a lot rapidly. So the remaining half is really going to be reliant on technologies that just aren't yet ready today, right? A lot of them are still in prototype stage or demonstration stage. There's a lot of work to do on that front, and it's not going to be easy. So what we need to reduce those emissions is really a two-sided effect. So on the one hand, we've got to dramatically, reduce our dependency on fossil fuels, which are really driving a lot of the emissions annually. And then on the other hand, we've got to deploy and scale up a lot of these new green technologies. And in our BCG world, we really see 8 technologies as actually being, absolutely critical to this effort. So we've got low carbon hydrogen and synthetic fuels, bioenergy, carbon removal, CCUS, green building tech, so that includes things like building automation and biomaterials, distributed energy, as well as green factory related technologies. And this is by no means exhaustive. There's going to be other types of technologies, but these are the ones that we believe have huge potential. So if we take low carbon hydrogen, for example, we're looking at a potential reduction of 25% of those emissions once they're actually adopted at scale with the use cases like heavy road transport, aviation, steel, and so on. And if we look into technology readiness levels, a lot of them are actually at very different stages, and nothing is actually ready, right, for this mass industrialization stage that we see on this side over here. So we've got things like bioenergy that may be sort of more in that early adoption stage. However, most of them are still at that prototype and demonstration stage. So a huge need to really figure out how do we deploy these things quickly. And what's really interesting is, we've had some historical examples of green tech, like solar, like wind, and so on. But when it comes to these new technologies, a lot of them have got to be brought to market by 2030 latest. So in this net zero by 2050 scenario, we're looking at deployment scales that are much faster, in a magnitude of like 2 to 3 times faster than prior green technologies. Again, not an easy task, right? How are we going to do that? And what we're really seeing is in this green tech space, there's essentially 6 key hurdles that players really need to overcome. Right, so this involves everything from the product and process development, right? So ensuring that the technology itself is actually ready to be able to scale up, right? So what are the manufacturing specs? How do you actually set up the right operations so that we can actually then get ready to the next stage, which is setting up multiple factories. So getting the permits in place, the equipment, the tools, and so on. And then talent sourcing, right? I've spoken to many people at this conference who have been saying, right, that the talent shortage is real in this space. So not only do you need the technical component, but there's also the commercial component, and then that whole wrapper of an HR function that's able to actually effectively scale up the organization quickly, right, in this time scale required. And then the supply chain, right? So in some cases, we're dealing with scarce resources. So how do you actually set up these supply chains, ensure access to the raw materials readily, availably at all times, and then even working with end users to ensure, right, that they're actually able to use the technology, and that may actually involve iterations to the tech so that it can be deployed and used. And then around that, fundraising. So that's a huge topic in this space, and I've seen lots of people trickling out of the finance stage over there. But yeah, how do you get the right funding right across this entire journey where the risk and return profile is not really common, right, to a lot of these investors? And even with project financing, for example, they're typically more used to types of assets that are sort of more predictable in this space. And that brings me to the next point, right? So those hurdles, that's a lot to go through. And I think in a typical, innovation process, you would actually start with the product and process development and then move through commercial steps. But in this space, we've actually got to do all of those steps in parallel, right? And in the time frame that we've got, less than 30 years, we can't do it alone, right? No one company, no matter how vertically integrated they are across the value chain, is going to be able to accomplish this on their own. And that's why in this space, ecosystems are of massive importance. So we've got to be able to pool together, complementary organizations that each bring, a distinct role, capability, and levels of expertise to be able to work together to actually overcome these hurdles. And in our view, we really see this ecosystem as being a variety of players that sit around the tech developers, right? So you've got your complementers and suppliers to that technology. You've also got catalysts that are able to really amplify the impact of that tech. And in many cases, we're also seeing a need for kind of an independent orchestrator who's actually able to figure out, hey, where do we actually need coordination across this ecosystem, pull together the right folks, and in some cases even set up the right operating model for these players to coordinate with each other, because sometimes they're really not used to coordinating with each other, and they may have to think about new types of systems and setups. So that's a brief introduction to the topic, and we've actually just published a report specifically on this yesterday that I'll share the QR code for at the end of the entire session. But I wanted to hand it over to Vuk, who's actually going to introduce us to our amazing panelists, who can actually talk to us about the real world experience of scaling up their technologies.
Okay, thank you. First and foremost, I hope this will work from, let me take this headset. Oh no, do I need both? No, I don't. Anyway, I think this is going to be easier. So in order to illustrate this journey a little bit, we wanted to actually bring to the stage a few of the practitioners who are kind of working in this field, to share a little bit about how is their journey to actually scaling some of the new approaches and new technologies as well. And we have Amy and Ben and Hanan as well, and they are actually representing a sort of different end and different spectrum of the ecosystem as well. Hanan is kind of coming from us to us from Morocco directly, if I'm not mistaken, with representing a very proud Moroccan company, OCP. It's probably one of the most important global companies that you've never heard of, being one of the leaders in kind of fertilizer space and being absolutely key to the food security and food supply as well. They're doing some really interesting work across the range of innovation models in climate and sustainability, and we'd love to hear a little bit more about that. We have Amy. Amy is actually a proud alumna of BCG network, now putting in practice great skills that she gathered there in a company called Carbon Engineering, the leaders in the indirect air capture space. And it would be fascinating to hear a little bit how is that almost magical technology actually evolving and demystifying where does the magic and where does the hard work lie there. And finally, we have Ben. Ben is joining from Energy Dome, very ambitious, very high, fast scaling infrastructure startup. It's that kind of true green tech startup play of in long-term energy store. And he can tell us about the journey of bringing very new technology at scale at a really lightning fast pace as well. Welcome. And in terms of setup, I'd like to ask a few questions to our panelists first, but then actually open up a space for a few questions that you might have from the audience as well, that we can really turn this into an interesting and insightful discussion. And before we kick off, Hanan, why don't you tell us a little bit about what is it that OCP is actually doing in this space? Knowing a little bit more about it, we were really keen for you to tell this story, because we know that you're doing really interesting work at the core of your operations. You're doing really interesting work in a sort of extended ecosystem that you're working on, and also trying to actually conquer some of the boundaries of science as well.
Well, thank you very much for inviting me at this panel, and very happy to exchange about my company. OCP is the world-leading company in fertilizer production with 35% of the global market share. Let's say about $10 billion revenue is present in all the continents. We have clients all over the world, and our main operations are located in Morocco. We are also very committed to sustainability. We even conducted a holistic, let's say, work to embed sustainability targets in our core strategy and to avoid to have sustainability as a liar on the top of our operations. So we committed to be carbon neutral by 2040 on all our scopes 1, 2, and 3, direct and indirect emissions. And to be able to get this result, of course, innovation is very important, is a key component of the overall strategy. So when it comes to innovation, for us, we distinguish, of course, two main, let's say, levers. The first one is what we call the incremental innovation. So how to do in order to improve our existing facilities, operations, etc. For example, today, a big part of our direct emissions are coming from burning fossil fuels to dry phosphate before producing fertilizers. And of course, if we are able to adapt the existing machinery to consume hydrogen instead of fossil fuels and to burn hydrogen in the existing, green hydrogen in the existing furnaces, this will be a big layer and a big lever to embrace the neutrality on the emitted CO2 from our direct chimneys. So this is what we call for us the incremental one, is how to make it possible to improve the existing facilities and to adapt them to the energy transition requirements. But of course, it's not sufficient. We also rely on what we call the disruptive innovation or the deep tech innovation that we need also specifically for the indirect emission part. 70% of our indirect emissions are coming from the fertilizer application and also from the import of ammonia that we don't produce. So we need to, we committed to produce our own green ammonia in our country. We have enough solar resources, wind resources, very good quality, and we have all the competitive advantages to produce green hydrogen, green ammonia locally. So the first 1 million ton green ammonia will come by 2027. We are already conducting the pre-feasibility study for that. And we need definitely to choose the electrolysis technology that will fit with our existing conditions. But even if we are able to start with a higher price at the beginning and higher hydrogen costs and green ammonia costs, we aim to reduce the costs in the next phases, because we aim globally to produce 3 million tons of green ammonia by 2032. And of course, we need all the emerging technologies such as direct splitting of water, thermal electrolysis, etc. We rely on this, and this kind of disruptive innovation could really lead to this reduction of cost that we seek for. We also need to work on the carbon capture in soils. We consider it as an important lever in our strategy, since we work with farmers to implement what we call regenerative agricultural practices and enhance the capture of carbon in soils. This is our way to balance the part of emissions that we cannot reduce. And then to make it possible, we need digital tools to assess the carbon part of soils around the world and to do it quickly. So for this also, we just launched the pilot test in Brazil with some partners there to implement the LIPS technology. It's a laser spectroscopy to measure directly how much carbon we have in the beginning before the farmer starts its own.
To baseline, basically.
Baseline, exactly, and then to measure how have been captured with this regenerative practices. So without this kind of innovations, without this kind of new technologies, we will never be able to scale this proof of concepts that we are conducting. And this is how technology disruption is very important to make our carbon neutrality targets real. We invested in a university and invite you to look for the Mohammed VI Polytechnic University that is today handling all our R&D technology. It's becoming the biggest university in our country. We have also 11% of students coming from the African continent all over, partnering with great universities around the world, even in UK. And this university today is handling all our roadmap of technology, innovation, and deep technology to achieve our carbon neutrality targets. Thank you.
Thank you for sharing. I would like to come back to some of the topics that you raised, especially on a perspective from your vantage point. But one of the things you mentioned is, of course, carbon capture and the need to turn more of it from the atmosphere into somewhere else.
Exactly.
Amy, you came to this challenge almost with a blank slate, and you've chosen to actually engage with a direct air capture company. Tell us a little bit what was beyond your thought process and why you actually believe that actually working in a direct air capture is something the biggest way for your personal impact, but also for our innovation goals as well.
Yeah, so I'm with Carbon Engineering. We're a direct air capture technology company, and we've been capturing carbon dioxide from the atmosphere since 2015. When we capture that carbon dioxide, we can either send it back to where it came from, back to the geosphere, create a negative emission, 1 + -1 is 0, or we can use that carbon dioxide, combine it with clean hydrogen and create drop-in compatible products like sustainable aviation fuel. So my journey into the industry was through aviation. I was at the Boston Consulting Group for 10 years in the aviation practice, and then I moved to Virgin Atlantic, where I was VP of Corporate Development and Sustainability. So post-COVID, I was effectively working on all the growth areas of the airline and airlines in growth post-COVID. I just had that opportunity to move on to something that was my passion, and it was decarbonising that industry. So I just use it as a use case, as a hard-to-abate sector. If you've got a source of carbon dioxide somewhere that's concentrated, like a factory, of course you want to capture it from there. But not every industry is like that. You can't imagine having carbon capture on the back of an aeroplane. It would be too heavy. So two of the key decarbonisation pathways are carbon removals and power to liquids, or sustainable aviation fuels at scale, using carbon from the atmosphere as the carbon source. So that led me to join direct air capture a couple of years ago. We as a company are now focused on commercial scale deployment. So we license our technology. We realised quite early on that as a small company, we're not going to have the balance sheet, the ability to deploy these projects, these billion-dollar projects to capture CO2 from the atmosphere. So we license our technology. We're working with 1.5, that is a subsidiary of Oxy Low Carbon Ventures. And construction has started on our first large-scale plant out in Texas. When it's fully operational, 2025, it will be capturing 500,000 tonnes of carbon dioxide from the atmosphere each year. And we've already started the engineering on a second campus of plants on the Gulf Coast of Texas. That site has the ability to deploy up to 30 megatons of capture per year. So to put that into perspective, 30 megatons is almost the entire emissions of UK aviation. So where we're licensing our technology and 1.5 are deploying, our job as Carbon Engineering is innovation. We don't stop still. We work on what is the next generation of that technology. What I've said has been quite US focused. Why the US? It has the technical capabilities, it has storage, it has skill sets. There's a lot of overlapping skill sets between oil and gas and what we're trying to do. It has the ability to create renewable power, but also it has policy. The Inflation Reduction Act has been a huge catalyst for us. I think probably my final word would be, you can't do direct air capture unless you have customers. On top of the Inflation Reduction Act, we're seeing voluntary demand. So Airbus, for example, have had an offtake of 400,000 tonnes of carbon removal credits from this first plant. And recently, South Pole signed up for 200,000 tonnes of removals in total. They're going to be selling them on through their next generation facility, including BCG as one of the end customers.
That's great to hear. I'm looking forward to come back to some of the topics on scaling. I think that's going to be an interesting topic. But one thing that everybody doing direct air capture will need is ubiquitous amount of power as well. And then I think that's what Energy Dome is trying to tackle. And tell us a little bit, how are you actually moving into the next generation of long-term energy storage?
Sure. So Energy Dome is a long-duration energy storage technology company. Our mission is to make solar and wind power or any renewables completely dispatchable. Why long-duration energy storage? Well, there are broadly two pathways to deeply decarbonize the electric grid. One is nuclear fusion, and the other is long-duration energy storage, taking renewables and dispatching them when they're no longer available. Nuclear fusion has made great progress. The science is very promising, but we unfortunately still need to wait, and we don't have the time as society. So that leaves us with long duration energy storage. And our essential response to that is what we call the CO2 battery. So the CO2 battery is a thermodynamic transformation of carbon dioxide in a closed loop process. We take CO2 and we use it as a working fluid to store energy. The reason we use CO2 is because of the underlying physics of the molecule. So it's ironic we're using CO2, but it's not for marketing, it's because of physics. CO2 under under pressure at ambient temperature liquefies. And that property means that we have a high energy density fluid. It's about 66 kilowatt hours per cubic meter. And it's efficient because we can do it at ambient temperature, so we don't need cryogenic applications like liquid air energy storage does, for instance, which is lower efficiency and higher cost. So it's a combination of those two parameters why we've chosen CO2. Effectively, how it works is we have CO2 in essentially a big biogas holder in a discharge state. When there are abundant renewables on the grid, we will charge it. We basically pull power from the grid that feeds a motor. The motor then drives a compressor. It's the same compressor from the oil and gas industry, so we also have overlaps with existing supply chains. The compressor pulls the CO2 out of the dome, compresses it, generates heat, we store in a thermal energy storage device, and then we condense the CO2, liquefy it, and store it in high pressure, low volume CO2 vessels. So this is essentially when our battery is charged. The CO2 is in the liquid format, and the thermal energy storage is hot. When you want to dispatch the power, so when renewables are no longer available, we invert the process. So we evaporate the CO2, recover the heat from the thermal energy storage device, and then expand the hot CO2 under pressure through a turbine, which returns the power to the grid. And then the CO2 goes back as a gas into the dome. So you should think of the CO2 like a refrigerant in an air conditioning unit. We charge it in the beginning, and we use the same CO2 for 30 years plus. And what this translates into is a focus really on the daily cycling market. So we charge every day, dispatch every day, take the solar and shift it to night. And what's key for that is a high round trip efficiency and low cost. So our round trip efficiency is 75% AC to AC, medium voltage to medium voltage. CapEx, which is under half of lithium ion, no degradation for over 30 years, and then an OpEx of about 1% of CapEx per annum. So for a customer and for society as a whole, what they really need is the economics to come down for this technology in order to deploy more than 4 hours of duration.
Tell us a little bit what I find fascinating in, honestly, very technical discussion that sounds fascinating, but much more to the point. You're quite remarkable in actually going through that innovation cycle relatively fast, no? And can you tell us a little bit about what was that journey of almost fast forwarding the innovation journey, and how did you manage to go from an idea into proof of concepts into actually considerable funding? I don't want to speculate on numbers, but was it 75 million, if I'm not mistaken? And how is that journey been for you, and what did you do right on it, and what are the lessons to share?
There are two main reasons why we've been able to go so fast. We were founded just before the pandemic, and we've already got a commercial technology. We built a utility scale demonstration plant. We're now selling it around the world. The two main reasons are the nature of the technology itself, the design choices we made in the technology, and secondly, the team and skill set in the company. So on the technology itself, we deliberately designed the product such that we could use existing supply chains, off-the-shelf components, and inherently scalable supply chains. One of the lessons from the clean tech 1.0 bubble about 10 years ago, what the clean tech companies were trying to do is they were trying to tackle everything, and they took too many risks. Try to create a brand new component, no supply chain, no existing capital stack. So what we've done is we integrate known components in a novel process, but the components themselves have been in the market for over 5 decades. And we take the same supply chains which are currently selling to process, oil and gas and power industries. We use the balance sheets of the suppliers in their factories, and then we just provide a wrapper as a process. So that allowed us to build a demonstration plant in under 2 years. And I'll just give you an example of this. So when you design the product, we could have gone for a 50 megawatt compressor or 100 megawatt compressor, but there are only one or two OEMs globally which can deliver a compressor like that, and it's never really been done before. If we'd have gone for that compressor, we would have been more efficient. We would have taken 5 years to do a demonstration plant. Instead, we went for less efficiency, which is still quite high, 75%, but we bought the same compressors, which are being supplied to Exxon, mining applications, etc. And that allowed us to basically do it within 18 months. The second reason is the team. So it's very important to have the skills to be able to control the product and not rely on outside parties. So despite using external supply chains, we know the turbo machinery, the process engineering, better than many of these suppliers. We actually do the feed, the front end engineering design, the detail engineering, and we even specify the steeling systems to the component suppliers. So we say, this is how it is, we standardize it, we get competitive tension in the supply chain, and then they deliver according to our specs.
There is a fascinating story, but I want to build on it with Amy. And there was this question, Amy, you hinted at that actually a lot of the skills that we need are residing currently in oil and gas industry. And you're also collaborating with some of the players in that industry. Sometimes this feels counterintuitive, but I would love us to explain to us why does it make sense and what is it that we need from oil and gas industry and how do we actually turn them into a part of solution?
Yeah, and I was just nodding everything you're saying because we took the same philosophy and that's how we scaled up. I don't think it's counterintuitive. I think from the word go in my professional career, I've been taught that if you're going to do something, find the best team to do it. So look for the skill sets, look for the people best deployed to do it. And who knows how to handle gases? Who knows the geosphere? Who has been pumping gases back into the geosphere over the last few decades? Well, the oil and gas industry. So certainly on the transport and storage side, they are who you want to partner with. And I think there are people out there in our industry in renewables who have made statements around not working with oil and gas. But I think it's naive, and really like any company that is going to be doing the transport and storage is ultimately going to be taking geophysicists from that industry, so why not use the corporate structure that already exists? So I think both, when I think about Oxy that we're partnered with over in the Permian, they have been transporting and storing CO2 for 40 years. And then our plant looks like a large chemical plant. Who knows how to operate them? Well, again, yeah, or chemicals, and and then for us with our process, again, we took very similar principles in scaling up. So we use a commodity solvent. We didn't want to be building up a supply chain behind us. We use potassium hydroxide. OxyChem is I'm looking at my partner in the audience. I don't know whether it's the world's largest, but certainly the US largest producer of potassium hydroxide. So there's just all of those synergies with the industry.
Really illustrate the value of ecosystem approach as well.
Yeah.
That's fascinating. And then, Hanan, I'd like to come back to OCP as well, and I'd like to come back to some of those difficult trade-offs that sometimes we have to make. And you're really in sometimes unenviable position of having to think about, or to put it very poetically, how to feed the world, but also not contribute to further to climate change as well. How are you and your team members in OCP thinking about this conundrum, and how you're finding your way through it?
Well, definitely it seems like a dilemma when we think about food security and how much people do we need to feed, the growing demand year after year, and the climate change issue to address. But in fact, if we think about this, enhancing the soil quality is a necessary thing to produce more food, and capturing carbon in soils is also a way to enhance the quality of soil. So there is a nexus behind this overall system, and it seems even to be a reinforcing loop. So what we are doing in our company is that we are working on soil health, providing customized solutions, tailor-made fertilizers. We went through big soil mapping all over the world, and especially in Africa, when we mapped more than 15 million hectares to define exactly what are the needs of each soil and each crop. And we moved from 4 types of fertilizers to more than 50 types today, fully customized. Each region of the country, of the continent, have its own need. When you go, for example, to Ethiopia, they probably need less phosphorus than what we used to give them, but they need a little bit more sulfur because the soil lacks sulfur. So then we did this soil mapping, and we produced this tailor-made fertilizers, science-based. We worked hand in hand with the end users, that are the smallholder farmers. We went through caravans, training programs, etc., with different countries. We worked with local stakeholders, universities, institutions, etc., to bring end-to-end solutions for soil health. And then we have sometimes even reached 35% to even 40% more yield with the same piece of land. So this is very important in terms of environmental impact, in terms of CO2 release impact, because you don't bring much excess of nutrient that the soil and the farmer don't need and they cannot absorb, and then you find it in the end in the atmosphere. But you also bring more reliability to soil, and you can enhance the crop, yield. By working also on carbon capture in soils, we definitely rise the amount of carbon content in soil, so we have more yield in this. And at the same time is a carbon sink, natural carbon sink that we are leveraging to reduce the CO2 emissions at the farmer gate, and to directly reduce our indirect emissions through the farmer activity.
That's super interesting, but there's one more aspect that I'd love to dive into. You described how you were quite literally on the front line of actually impact of climate change, and you mentioned some very fragile ecosystems and very fragile societies in a way. I'd love to share with us a little bit, how does this perception, but also action on climate change need to look like from perhaps global perspective and perspective of global south? Is there any messages that you can pass on to us?
Yeah, I think that we always talk about the climate justice issue and how Africa is responsible for 2% of the CO2 emissions, global CO2 emissions, but big parts like the sub-Saharan Africa is today facing a big hit from the climate change impacts, and climate transition should also integrate the climate justice concept. But in fact, it's, for me, becoming more a win-win relationship, because all of the Western society need today the African continent to make the climate change transition, the climate transition happen. If you want to produce green hydrogen, if you want to feed the northern countries with new renewable resources, there is a lot to come from Africa and from the African continent. Big resources in solar, in terms of solar and wind availability. Lots of non-used land that could serve to bring big capacities of solar and wind farms, etc. So I see it today more a win-win and a must-win battle when it comes to, a partnership around climate transition rather than a climate justice issue.
That's great to hear. And let's talk a little bit about how do we actually accelerate that scaling even faster, and then we will need an energy storage, more of it coming online. What are your plans to make that happen? But perhaps what is the biggest obstacle in your way that you wish you could do away with the magic wand?
There are many obstacles, if we're totally honest about it. I would say the two largest challenges are market adoption and capital intensity. Right? So, and the risks, right, which interplay between the two of them. So firstly, just on market adoption. When you're trying to do something new, and in particular, the customer is fairly conservative, risk-averse, generally looking at solutions in the past, that does take time, and that kind of is a bit of an oil and water mix with a startup or a scale-up, which is trying to grow much faster. So you have to very quickly calibrate with the customer and the wider ecosystem to do that. What we're facing in long duration energy storage space, and this is 8 to 24 hours duration, is that the market signals and mechanisms are not quite there yet as they are for under 4 hours. So for instance, to stabilize the grid, there's frequency control, voltage regulation, which ensures that the lights are on, basically when you turn the lights on.
The famous 50 hertz or whatever, yeah?
Yeah, 50 hertz, 60 hertz, etc. So for the short duration, there's already signals and then mechanisms which are basically policy based, which allow you to at least get some revenue, and then you stack on top of that some kind of trading or arbitrage. And that's what lithium ion does for about 4 hours. Lithium ion is not economic beyond 4 hours, right? Which is why we've got the problem. We don't have technology beyond 4 hours. So on the one hand, we need some policy signals and to provide procurement of long duration energy storage and targets. So by the way, we have targets for renewable energy, but you can't get the penetration of renewable energy into the grid without the long duration energy storage. So we need some coherency between targets of renewables and the storage, and then the market signals to make that happen. And then with a private customer, right? So whether it's a heavy energy user or a utility, that is a very intense kind of due diligence process. It'll take 5 engineers, for instance, for us, 2 months to do technical qualification with one customer. So that on the market adoption side, that can slow things down. I could talk about the other side later.
Exactly. And then a similar question, but in different direction to you, Amy, because it's a typical story. It's like, yeah, direct air capture, oh, very nice, yeah, we love it, but actually it's expensive. Is that true? And how is that cost curve evolving?
Using the word expensive is always relative. Expensive to what? So I'd start with the first premise that if we want to stay in a world that is probably not 1.5 degrees at this point, but let's say 2 degrees. And the Intergovernmental Panel on Climate Change, the IPCC, says we're going to need billions of tons of removals. How do you do that at scale? Well, direct air capture really is the scalable technology. So I sort of start from the premise that we want to get there, so we need to do something, and the benchmark is the cost of doing nothing. But then the other benchmark I'll look at is what's being used today to decarbonise. You look at something like sustainable aviation fuels and the price they're selling for in the European market, and you back out what that carbon price is, and you get to around €500 per tonne. So you've got very obvious carbon pricing within the ETS, but less obvious is within fuel policies. So more is being paid today than direct air capture and sequestration. And so Oxy have put out estimates for the first plant. They said for this first of a kind that I'm talking about, $400 to $500 per tonne. By 2030, around 200 to 250, and then in manufacturing mode, 125 or so. So those are the targets, and it all takes deployment. I mean, the other benchmark people would always talk about is when it's carbon removal, nature-based solutions. And they definitely have a place, but they are doing different things. The durability of storing in forestry, for example, is in the hundreds of years at best. We're talking about effectively permanent removals, millennia. So I don't think you're not comparing apples to apples.
Yeah, it's super perspective. Now, in order not to just keep asking questions myself, I would just like to prompt the audience of whether there's any questions coming up. If I'm not mistaken, Walid, why don't you kick us off, no?
Good eyes, thank you. Just to bounce back on what you were saying, Amy, I'm just a little bit curious. I was asking myself when we heard 1.5 before. So we're saying direct air capture was scaling, would drop the price at scale. And so what would be the incentive of carbon buyers to buy carbon now at $400 or $500 a ton, thinking that in a few years the price will drastically come down? Particularly on the voluntary markets, right?
Yeah.
And to be fair, we're facing the same issue, so I'm just wondering.
It's maybe worth repeating because I don't know how well people can hear, but it's what incentivizes voluntary buyers to buy now, knowing that we're going down a cost reduction curve. My short answer is, without buyers now, you never go down that curve. So if you don't deploy, it won't be available. And I go back to aviation, my background, but the same is true of, so within aviation, I think you have a bit of an existential crisis that if you can't decarbonize, you don't have a right to exist as a sector. So you need to make sure that solution's available, and that means early adoption. And I'd also say, like, when corporates are thinking about these things, like, I go back to my BCG days, and you look at the footprint of BCG. I don't know, I'm no longer at the company, but I'd hazard a guess that the major hard to abate emission is from employee travel, is the scope 3. So again, it's back to that aviation. So again, nobody starts buying now, the solution's not available. So, you know, that's the incentive. And then there's commercial discussions, right? If you're first in, then maybe you can get better deals later. Yeah.
I would just say there is another incentive. So if you hit $250 a ton of CO2, we'll buy it. Right? So it's not just about the carbon market, it's also about
as an uptakers in feedstock and other processes. Although I'm hearing that you don't actually change CO2 so much in your installations, no?
So yes, we don't need that much. So it's about 2,600 metric tons per 200 megawatt hour. But we need terawatt hours of storage. Right? So
we had this discussion outside. So how much can we sell?
And I think it illustrates very nicely the point that we're actually building new value chains and we're building new ecosystems. It's coming back to that point on innovation and on connectivity as well. But let me open up for one more question. Sorry, I couldn't catch your name in the same way I could previously. Leon.
Actually, it will develop on what have just been said about the ecosystems, because the presentations that we hear, they are really more about individual companies and the individual products. You go after customers, develop your markets, but nobody really focused on ecosystems and why you need an ecosystem. BCG naturally promotes this concept, but is there any value for you? I didn't hear that.
I would love to actually hear first what Stefan thinks about it before passing on to some of the startups as well. Not to put you on the spot, Stefan, but what is that? Where is that?
Wow, but that's funny. Look, I think I'm looking forward to you guys answering the question, but I think the reality is all of you are probably working in pretty tight ecosystems together with your supplier network, for example, with the industry you're supplying to. So I think it's naive to believe that any single company can address these issues on their own. And as a matter of fact, you need a broad ecosystem. You also need regulation in most situations. You need the government to help you drive your market forward. So I think all of the businesses actually work in very tight relationships across the industries and even beyond the industries to make happen what they do. But then you guys have a couple to answer this question.
On the technology side, I kind of had it as a given because we've got another panelist, but you need renewables to be built out at scale, and renewables means that you need energy storage. So everything that you've said is part of our ecosystem. We need transport and storage of carbon dioxide, and within the UK that's being done on a cluster approach. It's common infrastructure, so the way that a factory is decarbonising, we'll be tapping into that common infrastructure. And then on the market creation side, we don't have compliance markets today to sell our product into. We collaborate with other carbon removal companies. We're members of the negative emissions platform in Brussels, and that's all about collaboration across the industry. So I'd say that we do very little on our own, and everything's an ecosystem.
And please.
I can just give two concrete examples of collaboration. So OCP wants to do green ammonia, right? Or green hydrogen or hydrogen derivative. To do green hydrogen, you need electrolyzers, which split the water through electrolysis. To run an electrolyzer profitably, you need to increase the capacity factor of that, which means you need to basically run it at night, which means that the renewables need to be available at night, which means you need long duration energy storage. So long duration energy storage is an enabler for the green hydrogen itself, an enabler for the user of it. And so that's one area where we're working together. And specifically, there's an electrolyzer manufacturer in Europe with whom we're working because we've got a very common problem. We do hardware, they do hardware. Bringing new hardware into the market where each system costs $50 million is extremely risky. Yeah, you need to provide performance guarantees. So they have the exact same financial scale-up issues that we have. And we're working together, together with policymakers and third-party third parties in the capital markets to shift risk of our balance sheet into the capital markets.
I would like to jump in here quickly,
Please do.
just to build on the same ideas. Today, driving an ecosystem development when it comes to an industrial big projects such as the green ammonia projects is a must because it's the best way to drive the costs down. For our case, we are planning to integrate locally 70% of the oil components that we need in our first 1 million ton of green ammonia because it does not make sense to import wind blades or to import electrolyzers when we have a long-term view on green ammonia production. So driving the cost down is a must, and then the ecosystem is the way to do it. Also, when you build an ecosystem around your own program, then it enables also new opportunities for downstream integration. Of course, we are planning to have green ammonia, but once we have green hydrogen with some CO2 around us, we can produce green ammonia, for green methanol, sorry, then hydrogen could be a way to develop a new green steel local industry instead of, let's say, transporting hydrogen to Europe to make green steel. So we should also look at the ecosystem as a way to be more efficient and to drive the costs down. This is the point.
Yeah, so we have a lot of like technical people around, some consulting people as well, and I think it was mentioned that the green tech is a little behind. So with the new advancement technologies like AI and ChatGPT we keep hearing about, what's your perspective as to how it can accelerate the design and deployment of these green tech?
Who feels confident answering this question?
Can you just repeat the question?
The question is essentially, as I understood it, it's essentially how can we use the advances, especially on a digital front in AI, and we're hearing a lot about ChatGPT as the latest technological boom, of how do we bring those to bear onto our missions as well. I know we have a perspective as BCG. I was wondering whether some of the panelists do or whether we should start with our own.
I am not the expert. I can give, so I actually went back to the BCG London office this week, and I spoke to a partner that I work there a lot with, and he'd been to the worldwide partner meeting of BCG and heard that you guys talked a lot about it. So then we got to how it could help us, and this is just one example, but we've been thinking a lot about going from a world where we're deploying, or specifically 1.5 or Oxy is deploying 1 or 2 large infrastructure projects a year. And you can do that in a way that is quite bespoke because you have a lot of experts who know their stuff and they don't need to follow to the letter standard operating procedures. They can adapt them as they go. You get to the point where you're trying to deploy tens, hundreds of these plants, and you need that standardization. You could spend all of your time training up people to do those procedures and staff up kind of a Q&A control tower, or you could use AI as a way to ask those questions. So it's one very specific example which came out of a BCG discussion.
Annika or Stefan, can you tell us what's going on what's your perspective on it?
So we believe that AI is going to be a key enabler of climate technology in a number of ways. At the end of the day, the key capability of AI is to analyze huge amounts of data, and you need to do that in numerous ways to address climate change. It starts with understanding the current footprint as a company. Ultimately that's a question of analyzing data, understanding the impact climate change has on certain parts of your ecosystem, simulating that. Is leveraging AI already. Understanding and prioritizing levers which you have as a company or steps you take to reduce emissions along your value chain. Again, it's a matter of simulation. But also understanding, tracking your own emission footprint across the value chain. So all of these leveraging, data from satellites, or generally from space technology, to better understand changes in the ecosystem, the ability to store CO2 in natural environments and so forth. So all of this is ultimately a result of analyzing large amounts of data, which has only become available as of recently. So we absolutely believe that it's a big enabler of the entire climate technology, and only really at the beginning.
So I just wanted to bring a few different strands in our talk today. First of all, from the sort of third challenge about talent, we've also talked about market adoption and the role of AI as well as the entire ecosystem. In my mind, I'm also wondering how we get enough people interested in getting the skills necessary to translate from wherever. We know AI can help accelerate people's education and moving into tech. What is your vision for how people with no data background, no tech background, maybe not even the functional skills, try and translate that into having a positive impact?
Sorry, allow me to sum up. And question is almost like, how does everybody do their part, regardless of the kind of amount of scientific skills that we have? And maybe we have a panel that is a little intimidating in terms of the scientific approach. And if I might ask, Hanan, what was your experience in OCP? Because again, you're working with those smallholder farmers. How are they talking and thinking about this problem? And what is the messages that you're hearing from that?
I think the main thing that come up after all the interaction that we have with the smallholder farmers is the lack of training and capabilities. Lack of training and capabilities when it comes, for example, to how to apply fertilizer, what are the good sorts, the good types, when, where, etc. There is a very famous, let's say, concept in the fertilization area that is called the 4R framework. The right nutrients for the right crop, the right time, with the right amount. So in order to help farmers to get the best of the results of the money that they're putting in fertilizers, you need to train them on this framework, and then there is effectively a lack of infrastructure, a lack of reach to the smallholder farmer that even today faces a lack of the go-to-market, of access to fertilizers, etc. So the infrastructure that we built around the university is helping to get these systems, these programs to train farmers on these concepts and to get more value from their investment in fertilizers and soil solutions. I don't know if I gave you a concrete example to address how innovation and how science could be served to all the partners around the, let's say, the supply chain. To get the result in the end, you need to strengthen capabilities and to work on training your stakeholders to get the maximum efficiency of the whole system.
Thank you, thank you. Sorry, before we have to announce a late but very welcome guest, Irina Gorbunova, if I'm pronouncing this correctly, a leader of XCarb, or should I say, an investment vehicle in a steel industry. And you actually have a privileged position of seeing a lot of really impactful innovation and investing in them. In order to round off the panel, I'd love to hear what makes you optimistic when you look at the field of green tech innovation today.
Thank you. That's an excellent question. I think, first of all, steel is decarbonization of steelmaking is a very complex challenge. And if you look at the way currently steel is produced, for every ton of steel we produce, it's around 1.8 tons of CO2 being emitted. So given the global production of close to 2 billion tons, it results in a very significant carbon footprint, which is just below 10% of global CO2 emissions. So it's a very ambitious challenge. Nevertheless, we as a group, I work for ArcelorMittal, so I run our corporate venture capital fund, which is called XCarb Innovation Fund. So we've pledged to become carbon neutral by 2050. We have a number of technology pathways that we are working on to get to the low carbon or zero carbon steel. And in addition to that, we launched the venture capital fund to support some of those most disruptive breakthrough and innovative technologies in order to accelerate our decarbonization journey. What makes me optimistic is that since we launched, I was actually quite positively impressed by a number of innovators we met, by a number of interested early stage and started and very early stage technologies that are working on some of those solutions across the value chain. Yesterday I was speaking to one of the venture capital funds who said, well, you're only looking at steel, so your focus is so limited. Well, if you look at the whole value chain, regardless of the technology pathway, we need clean energy, we need clean electricity. So we are investing in renewable energy. Then, of course, there is an issue of intermittent nature of the renewable energy. So we are looking at the energy storage solutions. We're looking at the circularity of the circular economy business. So there are so many technologies across the value chain that we are focused on, which makes it quite broad. And what makes me optimistic again, it's not just one solution, but there are a number of things that we can work on in supporting some of those startups. So since we launched the funds, we already invested in renewable energy, nuclear, because I think nuclear has to be part of renewable energy mix. In the long duration energy storage, the company called FOM Energy, which is developing a low-cost, long-duration energy storage. In a novel hydrogen technology called H2Pro, it's an Israeli startup developing a hydrogen technology without using a membrane, which is one of the most costly elements in the green hydrogen generation and production. We also, like I said, I believe in circularity. So we invested in a company called LanzaTech, which is using the recycled CO2, the recycled gases to produce bioethanol, which is again a great example of a technology which you take waste and you produce something valuable. Most recently, I invested in a company called Boston Metal, which is really the core of steel making. It's a direct electrolysis of iron ore, so they use a molten oxide electrolysis to produce steel. So a number of things to be optimistic about.
And to be optimistic about. And I think one thing that gives me optimism is all of the questions from the field, but I believe we only have space for one more. So please, why don't you do us the honor for the last one?
Thank you. Yeah, I presume that before deployment, you had to build your own pilot plants. How did you fund this? And did you work with any partners, like your clients, together with them?
Great question on essentially how to get going, how to get over that first initial technology. Ben and Amy, I think this one's squarely aimed at you.
You go first.
Fantastic question. So basically, the demonstration plant is essential, right? If you're bringing a new product to market, especially on the hardware side. That's your kind of key de-risker, right? To show that the proposition works from a technology perspective. And then you move to product market fit, right? Where the people actually buy it, right? From a funding perspective, nowadays there is a very, very healthy ecosystem. So from a venture perspective, you start off with angel investors to get your first funding, right? The prototype before the demo. And then typically raise a Series A, which is when you get your first professional investor, which leads a round of a substantial amount of capital, where you raise just enough to then build the demonstration plant. So in our case, we raised $10 million, and because our components were off the shelf, we were able to build it quite quickly, right? And then thereafter, you basically have this gap in the market for funding where you need to raise $50 to $100 million, but you're not yet at growth stage. And that's where the valley of death is quite long and wide, right? And there are lots of corpses along the way. So that's where it can get quite tricky. But fortunately now there are a lot of strategic investors. And funnily enough, the skills to assess deep technologies are not necessarily on the financial investors. They don't really necessarily have that background, right? And they often rely on consultants, but often the skills are actually in strategic investors because they can really look at it and they can have the conviction to make a bet at that stage between your demonstration plant and before you're able to attract big institutional capital.
He said it all. I would just add, we went through the same journey. Strategics came in, Oxy came in at our strategic stage. They complement what we bring. We can develop technology, they can deploy technology. So, yeah, you said it all.
Good. I think we're coming up with time for our session. I'd like to thank all of you panelists, audience for super questions and engagements. Thank you for panelists. What gives me reason for optimism if we solve materials and steel, if we solve fuel and transport, if we solve energy, and finally food, we'll be a long way in a much better world. Looking forward to seeing the impact that you make. Thank you.